Well, good morning or good afternoon, let's say good day, everybody. And my comment for English language, following to Wayne's comment, is that I hope that I will speak in understandable English, because English is not my mother language, but I hope that will give you to understand what I would like to say you. Once again, I would like to thank the organizers. The first one was at the dinner time yesterday, for inviting me to participate in this important event. What I'm going to present today in my speech is to try to summarize all the information referred on coal fly ash, properties, elemental composition, organic pollutants in coal fly ash, opportunities and challenges in the use of this material for soil improvements, the influence of coal ash on plant growth and pollutants, the recent advances made in single and multi-component utilization of coal ash, use of coal fly ash for remediation of contaminated soils, and finally, one thing that I find is very important, to open the discussion about the impact of coal fly ash on amendment on soil carbon. Okay. We heard this morning and all these days several information about coal fly ash, several definitions, several descriptions of the coal combustion products. For me, from all these categories of coal combustion byproducts, I will keep the last one, fly ash. Fly ash as the fine ash produced in coal-fired power station, collected by using electrostatic precipitators. It comprises about 85%. It's almost the biggest fraction of the coal fly ash, and it will be abbreviated in my presentation as CFA. Okay, from the beginning, I would like to just to give an information about the classification of coal fly ash. This is categorized, this is classified in two classes, Class C and Class F. The first one, the most important characteristics is that it contains high amount in calcium oxide, and it can be used for soil acidity amelioration. And the Class F, which contains calcium oxide less than 20%, and it may contain lower proportion of crystalline components, but also it has some pozzolanic properties. It is significant to remember this, because when we use fly ash to soil, we have to focus on what we want to do with these soils, which is the problem of the soil, and using fly ash, how we can use it to ameliorate this problem. Okay, let's start from the first and easy property, pH and electrical conductivity. pH of fly ashes ranges very widely, from acid, very acid, depending on the materials that are used in power plants, and it can range from 4.5 up to 13. Electrical conductivity. Since fly ash is just a sum of salts, it has high electrical conductivity. When we dissolve salts in water, the electrical conductivity is very high. So it can reach up to 20 decisiemens per meter. Mineralogical properties, very quickly. It contains glassy particles 50 to 90%. crystal particles, very small amount. Unburned coal, sometimes it's high, it's up to 15%. It's an important characteristic when we want to increase organic matter content, organic carbon of soils. Magnetite, hematite, quartz, mullite, free calcium carbonate, like in this slide. Physical properties now. Texture. Texture is usually in silty loam class. It's not a good characteristic, as it was mentioned before by the colleague. And the other important characteristic is specific surface. It is very high, and on this property we are based to use fly ash for absorbing toxic elements. Specific gravity is 1 to 1.8 gram per centimeter. Water holding capacity 35 to 40%. Porosity 50 to 60%. As I told before, unburned coal sometimes more than 10%, and the color is from white to red. Okay, let's see now what happens about elemental composition, because from our point of view, from the use that we have in my country for fly ash so far, is to use fly ash as a partial substitute of fertilizers and soil amelioration of acid soils. So from this point of view, we can see that nitrogen, very low. Aluminum, it's about like less than in soils. Calcium, iron, potassium, not so high. Again, magnesium, phosphorus, and sulfur. We can say that these characteristics, these essential to plant growth elements, fly ash is poor, is low. So now, on trace elements. In trace elements, both essential elements as well as toxic elements are included. For example, we can see that fly ash can contain arsenic, a very, very toxic element. Boron. Excuse me. Yeah, boron is an essential element, and very often we can see problems in nutrition of crops with boron. For example, in olives. So we can keep this in our mind when we want to use this as fertilizer. Cadmium, chromium, and all these elements, and you can see in some places the concentration of toxic metals is very high, so we have to be very careful, because before we decide to use fly ash for soils. Another important pollutant, organic pollutants. If we can try to see what happens in the literature, you can see that in fly ash we can find very toxic organic pollutants, polycyclic aromatic hydrocarbons and polychlorinated biphenyls. All of us, I'm sure that you know that they are very toxic. They may cause serious problems in human health. So let's go now very quickly in the options that we have to manage fly ash. In this case, we can see that fly ash can be used as wasteland reclamation, for waste stabilization. We heard before some very good information by the previous speakers, for making bricks, a supplement of cement and concrete, for roads and embankments, and for preparing new products like zeolites, blackboard chalks, and ceramics, and of course in agriculture. And this is my main topic. So when we consider fly ash use in agriculture, we can summarize its effects on the land, like in this very good scheme. It is called, it is taken by a very good paper from Malik and Tafilal. Okay, let's see very quickly what are the effects of fly ash when we apply it in soils. Effects: it corrects soil pH, promote both better aeration and percolation and retention, provides micro and macro elements, essential nutrients to plant growth, and enhances growth and yield of different plant species in different agroclimatic conditions. If we use fly ash as amendment, soil amendment, we can see that it can be used like lime and gypsum. Depends on if it is acidic, we can use this as gypsum, and if it is alkaline, we can use this as lime. As organic, like poultry manure, sewage sludge, bioprocess waste, compost, farmyard manure. And also we must mention the effect of fly ash on bioaugmentation. The influence, namely the influence on mycorrhiza, blue-green algae, and rhizobium. And which are the constraints in categories? They are: it is an insert material and low water in general holding capacity material. It is deficient in organic content, mostly. It is deficient in the basic soil essential nutrients to plant growth, like carbon, nitrogen, and phosphorus. And sometimes may cause problems with pollution with toxic heavy metals. Okay, let's go now very quickly what happens when we apply fly ash in soil. pH correction. Here I'm trying to incorporate our results that we had in my country from research that we carried out during the last years. For example, pH correction in soils, in acid soils, we found that pH from 4.7, it was increased to 7.7, or from 5.6 to 6.7. It's a very good result. And as you can see later, it resulted in increase in plant growth and yield. So in the opposite case, when we have alkaline soils and when we use acid fly ashes, we may reduce soil pH and thus to increase availability of metals. Electrical conductivity, it is expectable. It was increased after applying fly ash. Textures. When we apply fly ash, depends on the texture of the soil that has, which will be the influence. If the soil is very loose, the texture of fly ash, silty loam, maybe is beneficial to be used because it enhances soil structure. But in other cases, the results would be not good. As the colleague told before, probably, okay, we may see that infiltration rate will increase, although in many cases, we can see that water holding capacity, aeration, percolation, and irritation improved. But there are also some cases that these properties were worse. Plant growth. There are several data, several papers in the literature that you can see that many plants, rice, tomato, ryegrass, and aromatic plants, after applying coal fly ash, you can see that the yield increases. Some of this information are presented in this slide. And why? Because in some cases we may see, if we examine in depth, in detail the data, we can see that some elements, not nitrogen and not phosphorus, and usually not potassium, but calcium sometimes, magnesium not so usually, and sulfur again no, but in many cases you can see that boron uptake was increased and helped the plants to increase their yield. Also, sometimes you can see that the opposite. For example, in mustard, you can see that copper content was decreased. And probably this is because the pH increased and the availability of copper decreased. Also zinc here and manganese, iron, molybdenum. In general, we can say that from this point of view, coal fly ash is not a good material to substitute fertilizer. It has very low nutritional value. Now in toxic elements, if someone can search all the data in the literature, the final impression that we'll get will be that no serious problems are from fly ash use in the soil. There are no many papers saying that toxic elements concentration in plant increases. Okay, let me now to show you some very quickly the results of some case studies in Greece some years ago with a program in cooperation with some colleagues from China. You know that China has a very big problem with fly ash management. We did some experiments, pot experiments, preliminary pot experiments, and later field experiments. From the pot experiments, the treatments and the details you can see here. You can see that here is soil, fly ash, and sewage sludge, because we try to see what happens if we apply together fly ash and sewage sludge. We did also adsorption experiments, and the results very quickly. Biomass production, you can see in the case that we use sewage sludge in the rates I showed before, increase significantly in these two cases, and it was due mainly to boron. And this was attributed to the boron increase due to fly ash application. You can see compared to the control, boron increased. Also, you can see that electrical conductivity increased, copper, lead, but not so much, nickel and zinc also increased. And also you can see some results on what happens in retention capacity of soil of toxic elements. And you can see here that copper distribution index was increased, as well as zinc, cadmium, and and lead. It means that when we apply fly ash, we increase retention capacity of these toxic elements. And this is a good case to, okay, I see. Okay. Now very quickly, the results of some field experiments. We used wheat. And in this case, we can see that fly ash application increased wheat yield, both in total biomass and in grain. It's a good encouraged result for us to persuade the people to start to think about using fly ash in their fields. Plant uptake, as we waited, no significant effects. Okay, and now just a few words about biological properties. Already you have heard on that. In general, fly ash application to soil affects microbial activity, and in cases that we have the bad results, it decreases microbial activity. But there are cases in which we improve soil properties, and we can see that microbial activity may increase. Now some constraints of coal fly ash application. The first one is related to the cost. If we have to transport, to carry fly ash from long distances, the farmers are not eager to pay. Probably they don't have to pay. So this is a problem. The other is to the pozzolanic nature of fly ash that may deteriorate soil properties. The other is that increases soil salinity, and in some cases increases toxic metal concentration. All these problems may be reduced when we apply fly ash with sewage sludge together. In these cases, we can see that the toxic effects of some elements may be reduced, and what the fly ash don't give us, for example, organic matter and mainly organic matter may be applied from sewage sludge. So it's a very good case to try to see the combination of using at the same time fly ash and materials containing organic matter like manure and okay, and yeah, just 2 seconds. Also, it is very well known from the literature that fly ash, in the previous lecture we saw that we can use fly ash to ameliorate soil acidity and thus to prevent leaching of toxic elements. And one that I'm going to, I'm waiting to discuss this after in the panel discussion is to see in depth what happens with relation to the impact of fly ash application to soil in carbon economy in soils, carbon sequestration. Someone can see in the literature that started to be published very interesting papers that open a window, open a road to this direction. Hope this afternoon to discuss this in detail and to reach some good results. Summary, the management of fly ash is a very serious problem worldwide. We heard what happens in India, in China, and other countries. And agricultural use seems to be a very good alternative, and many people started to think seriously about this. The advantage is that we can ameliorate some soil properties and increase plant growth, but at the same time, we said that there are some constraints. due to physical properties mainly and toxic elements and the application cost, but co-application of fly ash with sewage sludge may help to reduce these problems. That's all. Thank you for your attention. And we here